Here we have AP calculus AB problem. Okay, let's go the information. If f of 1 equals to 4 and f prime of 1 equals to 2, use the equation of tangent line to f at x equals to 1 to approximate f of 1.2. So our aim is to approximate the value of f of 1.2 using the equation of the tangent line to the graph of the function f. Okay, so before I start solving this question, let me consider an important stuff over here, that is y equals to f of x. So whenever we have a function, in this function we have f of x, sometimes we'll have g of x, sometimes we'll have h of x, whatever it is, it represents the value of the y coordinate in the xy plane. That is, it is equal to y. Okay, now let me consider the first piece of information, that is f of 1 equals to 4. That means when x equals to 1, the value of the function is 4. Let me write the stuff over here. When x equals to 1, so the value of the function f of x equals to 4. So just now we discussed that y equals to f of x. So we can replace this f of x by y, then we get y equals to 4. When x equals to 1, y equals to 4. And so x equals to 1 gives a point 1, 4 on the xy plane. So the point which is corresponding to x equals to 1 is 1, 4. Okay, now since we need the equation of tangent line to approximate the value of f of 1.2, first let me write the formula to get the equation of tangent line. Let me write it over here, equation of tangent line. Let me write it over here, tangent line. So the formula is y negative y1 equals to m times x negative x1. So actually this is point slope from equation of line. The same we use to get the equation of tangent line. In this one, x1 comma y1 is the point at where we draw the tangent line. So already we got the point which is corresponding to x equals to 1, because the question says use the equation of the tangent line to f at x equals to 1. So that is, we are going to draw tangent line to the graph of f of the function f of x at x equals to 1. For x equals to 1, the corresponding point is 1, 4. So that's x1, y1 equals to 1, 4. And we need the slope m. So how do I have to get the slope m? Actually, if I want to get the slope m of the tangent line to the graph of the function f of x, what I have to do is I have to find the first derivative of the function f of x. Then I have to evaluate the value of the first derivative at the given value of x, that is x equals to 1. So this f prime of 1 gives the slope of the tangent line at x equals to 1. Already we have this value, the value of f prime of 1 in the question, that is 2. So the slope of the tangent line at x equals to 1 is just 2, which is the value of f prime of 1. Okay, now what we have to do is we have to plug in this point x1, y1 and the slope m equals to 2 into the equation of the line over here. Okay, now let me do it. So y negative, the value of y1 is 4 and the value of m is 2, x negative, the value of x1 is 1. Okay, now let me do some simplification over here. Y negative 4 equals to, we can distribute this 2 to x and negative 1, then I'm getting 2x negative 2. Now we can add 4 to both sides to get the equation in slope intercept form. Negative 4 positive 4 will cancel, then y equals to 2x, and I combine negative 2 positive 4, I'm getting positive 2. Okay, now I got the equation of the line in slope intercept form. Already we know that y equals to f of x. Now this y can be replaced by f of x. Then I'm getting f of x equals to 2x positive 2. So this is the equation of the tangent line. Okay, now I'm going to use this equation of the tangent line to approximate f of 1.2. That means I have to plug in x equals to 1.2 over here. Let me do it. F of 1.2 equals to, on the right side also I have to plug in 1.2 for x. Then I'm getting f of 1.2 equals to 2 times 1.2 is 2.4 positive 2. So when I add 2.4 positive 2, I'm getting 4.4. Okay, using the equation of the tangent line to the graph of the function f, I have approximated the value of f of 1.2. So the approximate value of f of 1.2 is 4.4.